Hello everyone and welcome back to the Kohi Game Engine series. This time we are going to be tackling the saving and loading of binary meshes. So before we jump into the video, I would like to take a quick minute and thank the partners of the channel. The partners are the highest tier of support both on YouTube and Patreon, and they are Caden, Eearslya, Gerboles Inc., Kyla, Super Awesome, and Wensheng. I'd also like to thank all the other fine folks that appear on the screen here. Your support is greatly appreciated. Thank you very much. If you'd like to support the channel and support my work, feel free to have a look at the YouTube membership, or if you prefer Patreon, you can check out patreon.com/TravisVroman. Okay, so last time we set up our OBJ mesh loader, which does a lot of deduplication of vertices, which we see here running, and it takes quite some time to do this. And we mentioned that we really don't want to be doing this during runtime, that we really want something where this is already done. And so what we really need here is our own proprietary format. And that's what we're going to do here. It's going to be a format that is highly compatible with the data that the engine needs and the format that the engine actually needs it in. And so what we're going to do is we're going to write a binary file format where we can load that data in as, or at least parts of that data, the majority of the data, in as a large chunk and just feed it directly into memory and not have to do a whole bunch of processing and deduplication and things like that, because it'll make loading this much simpler. So we have our Sponza scene here, which is what takes all the time to load, as you guys have seen. So between that and the car here, it should actually save us quite a bit of time. So let's go ahead and exit out of that. Now before we do this, there are a couple of minor changes that I want to make. Not as many minor changes as the last video, because I know that went on pretty long. So this one is not going to be that. But what we want to do is we want to look at the geometry system.c file. And we actually want to include our geometry utils in here because we want to get rid of some repetitive code that we had in here previously. So I'm actually just going to move this up there. And what we're going to do is down here towards the bottom, where we are generating our cube config, we are actually going to generate the tangents here. And we're doing that because we don't want to have to do it in the application. That's kind of stupid. Doesn't really make much sense. So it makes more sense for us to do that here while we're generating all this config anyway. So that is the change to the geometry system. Now, obviously, that means that we need to go into the application.c, and we need to take a look at our cubes. And we can go ahead and, let's see, where were we even? So we have our generate tangents here. So we can remove that one. We can remove this one. And we can remove this one. All right, so that saves us a little bit there. And let me just check my notes here. I think that was actually, I believe that was actually all that we needed to do. Yeah, I think that was it. Okay, so the other thing that we are going to want to do is most of our work now is going to be in the mesh loader. So let's go ahead and load up the mesh loader. And I think actually all of this is going to be in the C file. I don't think we actually need to do anything in the header file whatsoever. So thankfully this is actually all pretty contained and should be pretty quick to get through. So we're going to first do our write KSM file because I think it makes sense to understand what we're writing out and what the, wow, keep hitting the wrong key. Makes sense to sort of understand what we're going to be writing out and what the file is going to look like on the out on the way out, and then reading it back in basically is just doing the opposite thing. So the first thing that we're going to want to do here is get rid of that to do and replace it with a file system exists check. And then if we determine that that it already exists, we're just going to actually output that it already exists and will be overwritten. So if we call the import function again and a KSM file already exists, which is not going to happen by default, but if we were to explicitly call that, it'll just override the KSM. So as we have done several other times, we go ahead and obtain a file handle. We just make sure to open that in write mode. And in this case, we are going to set binary to true because this is a binary file format that we're dealing with. If for some reason we fail, we bleat about it and boot. So next thing we're going to do is we are going to start writing to the file. So the first thing we're going to write out is the file version. This is the version of the file format, not necessarily the version of the model. I don't think we're going to maintain versions of that. Maybe if we have a packaging system, we might do it at that level, but at this level, it doesn't really make sense. So our version number for right now is just going to be 1. But if we ever increment this for backward compatibility issues, we'll need to vary on version number. So we're going to call our file system write, and we're just going to write those bytes, the size of a U16, directly to the file in binary. So the next thing we're going to write is we are going to write out the name of the particular geometry. Sorry, the name of the KSM object itself, the overarching object. So we're going to write that. We're going to do that by taking the length of the name, and we're going to write the length of that first as a U32. And then we're going to go ahead and write the name plus a null terminator. And what this will do is it will make sure that when we read it back in, we know how many bytes to read to get that string. Next, we're going to go ahead and write out the geometry count. So that is just the number of geometries we're going to be writing. We're just going to write that as a U32. And then we're going to go ahead and write each geometry. And this is basically just going to be a loop, as you might expect. So we'll just do right here. We'll take a pointer to the geometry, which is the address of geometry sub I. And the first thing that we're going to write is going to be the vertices. So right here, what we're doing is we're writing the right. So right here, we're writing the size of each individual vertex, which is can vary if we're using vertex 2D or vertex 3D. So that can vary. Remember, we have different formats of these that we can use. So we want to be compatible with all of those. And so we're going to write the size of each vertex. Then we're going to write the count of the vertices. And then we're actually going to write out the vertices themselves by taking the size times the count, telling us how much we're actually going to be writing out. And then the vertices themselves, we're going to take that as all one huge block and just slam it into the file. And so this will tell us how to interpret that on the way out as well. We're going to do the same thing with the indices. So we're going to take the indices, we're going to write out the size of an index, which in this case is the size of a U32. The index count is also going to be a U32, so we're going to write that out as well. And then we're going to take the entire array of indices, which is the index size times count, and we're going to write out the indices all in one shot. Next, we're going to write out the name of the individual geometry itself. So just like we did for name up here, we take the length of that, we write the length first. That way we know how many characters to actually read in when we're reading in the string. We are going to do the same exact thing for the material name. So the material name is just going to follow the exact same pattern. We take the length of it, we write the length, and then we write the string. We are going to write the center of the geometry next, which is just a vertex 3D. That's always going to be 3D, even if the geometry is a vec2. And we'll just ignore the z-axis. It was a lot easier to just do it that way than to try and figure it out any other way. And the same things are going to be true with the extents. Those are always going to be vector 3s, vertex 3Ds rather. That's probably not right, actually. That should be vector 3, not vertex 3D. Okay, so we're going to write those vector 3s, and then after we are done writing all that, close the file and we're done. That's it. That's all there is to writing it out. Okay. And so that is where we write that information out. And that should pretty much cover us in terms of actually creating that file. So that's the write. Now we can do the read. So the read is basically the exact opposite of what we just did. So we are going to first and foremost read in the version, because that was the first thing we wrote out before. It's a U16. We're going to then read in the name's length by calling file system read. It's the size of 32, U32 rather. Store that in name length, and then indicate the number of bytes that we read. We're going to use this on occasion to check. We might want to make this a little bit robust and actually check to make sure that we're reading the right amount of bytes, but for now, not going to worry about it. So we take the name plus the terminator and read it into this character array here. So we go ahead and read that using the length that we just read. Next, we go ahead and we read the geometry count, which again is just a U32, so pretty simple stuff there. And now we go through and read each geometry. And this is technically a step that we could probably read faster by just reading the whole thing in as one chunk, but I want to maintain the flexibility of not doing that, for at least right now, because as we change this, it's more than likely that we are going to wind up actually needing to fork here for different versions of the file. So the first thing we do is we create a local geometry config. We go ahead and read the vertices in the same order that we wrote them out. So we read the vertex size first, then the vertex count. Then we actually k-allocate an array to hold those vertices. And then we call file system read, where we read all those vertices at once and jam them into that array. We then do the exact same thing for indices. So indices just gets read in the exact same way. We take the size, the count, k-allocate an array, read all of the indices into that array directly. The name of the individual object is the same thing. We take the length, and then we read the name in at that length. Same thing for the material name. We take the length of the material name, read from the file, and we go ahead and we read the material name. We go ahead and we read the center. So that is going to be the size of vec3. This was actually wrong in my notes. I had a vertex 3D there, but it should be a vector 3 because that's all it actually is. Then we go ahead and read the extents, which is actually also going to be vector 3s. And then the only other thing that we'll have to do is we'll have to push this to the array of the out geometries D array. And if you recall here, we took a pointer to that array, so we need to dereference that here when we're pushing to it. And then we'll go ahead and close the file. And that should be all we need to do, because we actually take a pointer into that file. So that should be it. We go ahead and return true from there. And let's see. Let me just double check my notes here. So I think one more thing was, are we generating we're not generating the tangents in this as well, and we should really be doing that here and not having to do it in the application. So there's actually a couple places that we're doing this, and we really should only be doing it at one spot. So when we deduplicate, after we deduplicate, is when we should go ahead and generate our tangents. It doesn't make sense to do it before that because we don't want to be generating against a huge size, a huge array of vertices that we're just going to eliminate. It doesn't make sense to do that. It makes sense to do it after we deduplicate. So let's see. This is going to be, whoops, that is supposed to be actually inside this loop. Okay, and I think, let's just make sure that I got rid of all of these. I don't think I did. So yeah, we can get rid of this from here and get rid of it from here. Okay, so now the only places that should be doing it are when we generate our cube and when we generate or load up our OBJ files. Let's see, we're doing that for process subobject, but then we're also doing that on the import. Yeah, we shouldn't be doing it here actually either, because it's going to be done by the mesh loader after we run deduplication on all of the geometry. So actually, yeah, we were calculating the tangents twice there, and that's actually not needed. So let's go ahead and build this. What did I miss? Oh, it's unused now. That actually makes sense. Okay, let's build this again. We have another unused one. Yep. Don't need that anymore. Oh, now what? Incompatible. Geometry config. Each geometry. Right key some file. Geometries. So we have a pointer there. Eh? Oh, because it's technically turning it into a... Yeah, okay. I don't need the address of that. Okay. Whoopsies. Okay, I think that's right. So let's go ahead and run this. And we are going to have to go through that process of regenerating... well, generating the KSM and deduplicating the vertices. We're going to have to go through that one more time. Almost done. Okay. So what happened here? Segmentation fault. That's fun. What is the... Oh, that doesn't look like a valid address. What did we do here? Geometries. What index is this at? 1. 300. This has got to be the sponza. Okay. Geometries. Vertex size count. This is the first one though. So let me see. Geometries. Let's put a watch here. Let's just turn that into an array of 3. I think it's this one that we want. That is not correct. It has something to do with this, I think. What did I... Oh, right. this should not be a pointer to that array. We can just pass the array as is. So actually, yeah, I was thinking it was weird that it didn't want the address of this. I forgot. I have to change this. Let's see, we just passed that. This should be a single pointer. Right, and then this should be dereference. Now it should work. Or not. Did I shut that down last time? Let's rebuild it. All right, what did I miss here? Geometry. I thought geometry is not. Now it looks like it didn't even load. Okay. So we've got requires vertex data. What have I done? All right. Let's see. Failed to create geometry. Requires vertex data. So obviously, something has gone terribly wrong here. Let's see. Did I run into something? Dynamic allocator allocate requires a valid allocator and size. Oh yeah, I borked something. Let me have a look at... Actually, I don't need that. I could just do console.log. Okay, so that loaded fine. Huh. So I wonder what caused that issue. All right, what were the last... Let me just look at my diff here, because what were the last changes I made? It's not going to be that. That's taking in a dereference of that, which should be fine. I updated the definition of that too. Yep. So this still takes a double pointer, which it should. Let's see, I want this one. It's going to be something stupid and obvious, I'm sure. That's just tangents. It's not going to be that. It's not going to be that. That's just an auto format. It's not going to be that. All right, I guess I need to see what... I need to see what's causing this. So let's do a breakpoint here. And whenever I run into that, we can go up the call stack and see what the heck is causing that. So load KSM file. Oh, right. Okay, I think I'll bet I know what happened. Okay, so we had an issue when we were writing out a KSM file, and I'm willing to bet that now we have an invalid KSM file. So let's go here to models, and we have these KSM files here that were generated. Oh yeah, 1.7 kilobytes. Yeah, there's no way that guy's valid. Let's just get rid of those real quick. And because our write failed, it was finding the KSM file and trying to load it in, but it never finished actually writing the file out. So it wasn't loading anything, and that's what was failing. And you can see now that we've deleted that KSM file, it's now going through the whole process of re-importing the OBJ. Okay, so now we have loaded up, and you guys saw how long that took. It takes quite a bit of time, right, to actually get through loading that. But here we are. So now let's exit the application, and we're going to run it again, this time loading from the KSM file. Because the KSM file already exists, it's not going to load it from the OBJ. It's going to load it straight from the KSM, and boom. See how much faster that is. It's night and day, honestly. And so that is the benefit to using a format that your engine understands and can just read and write directly to a file. It becomes very, very quick to actually do that because you don't have to process it at all. You can just read it in as a huge chunk of data, and then boom, you're done. So that is pretty much it for this video, as opposed to the last video. The last video was quite a bit longer than this one. This one is quite a bit shorter. This one's not even going to be a half an hour long. So anyways, I hope you guys are liking the new direction of the series. Thank you so much for watching. And please toss me a like. Those really help me out, as do the comments. So please leave a comment if you have any questions, or just to give me feedback on the video series as a whole. I definitely value your guys' opinions on that stuff. So yeah. If you haven't subscribed already, feel free to do so to get more of this content as it comes out. So again, thank you guys so much for watching. I will see you guys next time.